All right, so this says consider the following data, and it says plot the data. So here, let me just label some of these points here. 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, and we have a point at 6, 6, which looks to be right there, and then 1, 7, and 3, 3, 2, 2, and 5, 14. So does there appear to be a relationship between x and y? Is it linear or nonlinear, weak or strong? It's really tough to say. I would say not strong, if any, relationship. Okay, so probably very weak relationship, if any. Alright, then it asks us to calculate the correlation coefficient. So here I have all of my x and y points, and so what I want to do is calculate my x minus x bar, and also my y minus y bar, and then the product. So here I have it's calculated the means for each of us. So I'm going to just do 6 minus 3.4. So I have 2.6. And just doing this quickly, I have negative 2.4, negative 0.4, negative 1.4, and this is going to be 1.6. Here I have negative 0.4, 0.6, negative 3.4. 2 minus 6.4 will be negative 4.4, and then 14 minus 6.4 gives me 7.6. It's having some issues here. Okay, and then so now I want to find the product of all of these things. Let's see if I have a better. So I have 2.6 times negative 0.4, which gives me negative 1.04, and negative 2.4 times 0.6 gives me negative 1.44, negative 0.4 times negative 3.4, 1.36, negative 1.4 times negative 4.4, 6.16, and finally 1.6 times 7.6 gives me 12.16. Okay, and so now the sum, I have to add all of these up, is going to give me negative 1.04 plus negative 1.44 plus 1.36 plus 6.16 plus 12.16. I get the sum of x minus x bar times y minus y bar equal to 17.2. And so to get my correlation coefficient, it's going to be 1 over n minus 1 times 1 over s sub x, s sub y of the sum. So this gives me 17.2, and I'm going to divide by 1, 2, 3, 4, 5. 5 minus 4, 5 minus 1 gives me 4, times standard deviation of x, which is 2.1, times the standard deviation of y, which is 4.7. So I have 17.2 divided by 4, divided by 2.1, divided by 4.7, and I get r is equal to 0.4357, so about 0.44. My correlation coefficient is about that much. Okay, and so now I want to ask, is this correlation significant? Yes or no? So this is going to give me a t-statistic, and my t-statistic is r times the square root of n minus 2 times 1 minus r squared. Okay, and our null hypothesis is that there is no correlation, and our alternative hypothesis is that there is correlation. Okay, so this is going to be a two-sided test, and so my t-statistic is going to be 0.44 times the square root of n is 5 minus 2, so I have 3 on the top, minus 1 minus 0.44 squared. So 1 minus 0.44 squared gives me that 0.86006. So I do 3 divided by that number, and I take the square root of that, and so I have 0.44 times 1.929, and multiply that by 0.44, and I have my t-statistic is equal to 0.859. So if I look up 0.859 in our t-table with 3 degrees of freedom, so I see that my p-value is going to be greater than 2 times 0.2, so my p-value is greater than 0.4, so I do not reject the no evidence of correlation.